talk a little bit about optional components. So there are a couple optional components. We already talked about the required ones, right? The management console, the flow collector, and the flow license. But there's a couple other ones you should be familiar with, and some that we'll touch on, specifically these two here that we'll touch on in the lab. The first one we want to talk about is the UDP director. The UDP director is completely optional. It is not required as part of the solution, and there are cases where companies are buying the UDP director outside of the Stealthwatch solution because of its capability. So the UDP director has the ability to take UDP telemetry information like NetFlow, syslog, and SNMP traps. You can target those types of conversations or telemetry information at the UDP director IP address. And then the UDP director has a simple, almost ACL-like policy internal that allows it to determine based on the inbound data being sent to it, whether it's NetFlow, syslog, or SNMP. The UDP director can then determine based on policy, where do I send this data? So this can be handy in environments where you have multiple flow collectors, or you know that you're going to start with 2 collectors and then maybe eventually get to 3, 4, 5 based on the scope and growth of this particular environment. What you can actually do is have the customer send all of their flow to the UDP director, and then have the UDP director make the determination of which collector to send that data to based on policy rules. So maybe some of the UDP or some of the net flow goes to flow collector 1, some goes to flow collector 2. Later on, when another collector is spun up, we can modify where the existing flow is going and maybe redirect additional flow if necessary. Additionally, same thing with syslog or SNMP trap, we can take that data in and redirect it. We can also redirect to multiple locations. So I could choose to take some of that flow or syslog and send it to the collector or another syslog engine, but I could also send it to 2 or 3 different destinations. This is where it becomes really handy for customers because, again, if they're leveraging NetFlow for multiple purposes, rather than having to go touch every router, switch, and firewall and define a second or third NetFlow destination and create all of that additional overhead on that platform, not to mention the change controls required for that to happen, if I can have them send all of their flow to the UDP director, I can now simply modify the UDP director configuration to say, I want you to send flow to flow collector 1, but I also want you to send it to the network team tool A and tool B. Now that single inbound flow from that router is being replicated to multiple destination networking management platforms. The UDP director does have an HA capability, but only on its largest model. So there are multiple physical models and their virtual edition as well. The 2000 series physical model can perform HA, and it is a true HA deployment where you actually, each appliance, physical appliance has an IP address, but there's also a VIP that it uses. So again, because this information can be quite critical coming from your network, your NetFlow, syslog, SNMP, et cetera, we want to make sure that that's not lost. So it's highly recommended in those types of environments that you deploy it HA with a pair of appliances and a VIP. So where do we place this then? Well, pretty straightforward architecturally in our solution. We want to make sure that if we're going to leverage a UDP director, that anything sending to the UDP director can reach it. So we want to put it in an appropriate location, whether it's geographically located or the data center. We want to make sure that makes sense. So we put that in such a location that the router switch firewall can send flow there, or other devices could send syslog or trap. And then we make sure that also the UDP director can replicate that data wherever it needs to go. In our case, the flow collector, but it could be other customer management solutions as well. Now, I do want to mention something here, and we are going to take you through in a lab scenario when you join the lab on a later date, this exact scenario, but it is important to understand when you have the UDP director, you can see a rule that we have on the screen here that is in all :2055 under the source IP column, that second column there in the middle of the screen. And that basically says that all flow, anything destined to UDP 2055, which is the common port for NetFlow, is going to be sent to that destination address on 2055, which is our exporter, or I'm sorry, our collector. So anything inbound on 2055 goes to our collector at .137. That's fine. Now all flow goes there. However, if you had multiple collectors you would actually have to have multiple rules telling it which sources sent to which collector. Now, once you get away from the all command here and you start to specifically define multiple rules saying half of the flow goes here and the other half goes there, and it's going to be very specific by IPs or IP ranges, it's important you maintain that moving forward, because if you spin up a new collector later and it doesn't happen to match any of the rules, it doesn't fall in any of the pre-existing defined rule ranges or specific IPs, that will not be forwarded. So even though the exporter is sending to the UDP director, the UDP director will only forward flows if it has a policy rule that matches. Also, it's not like a true ACL in that these policy rules are all processed for every packet, because Rule 1 may say send this type of data to flow collector 1, but Rule 2 may say for the same information, send it to network management tool 2. So again, it is going to process every rule. If you have 10 rules, every packet is going to be processed against every single one of those rules, and it may be replicated 1 time, 5 times, 10 times, or if there's no matching rule, it will not be replicated at all. So again, make sure you understand, if you do not generate a rule here for everything inbound, it will not be forwarded. So again, the final one we want to talk about is the flow sensor. So we've talked about management console, flow collector, net flow inbound, we talked about the UDP director, but now let's talk about the final Stealthwatch appliance here that we're going to talk about today, which is the flow sensor. The flow sensor is a device that has a promiscuous listening interface or multiple interfaces that can be used to generate net flow traffic from portions of the network that have no other way to do that for us. So as an example, you may have a new site that you acquired or your customer organization acquired, and that particular location doesn't have enterprise class gear. We see this quite commonly in healthcare, where you may have a situation that the hospital itself has enterprise class Cisco gear that is certainly NetFlow capable, but they just purchased a set of doctors' facilities or doctors' offices, and they're bringing that solution, that system, entire system under their IT management umbrella. Well, those doctors may not have purchased enterprise class gear. Maybe it was D-Link or something else, right? Some more consumer grade gear. So what would happen is, if we want to have visibility, we need to be able to generate flow. And there could be a gap between acquisition and getting enterprise class gear deployed. In the meantime, we have the option to deploy a flow sensor. Now the flow sensor would basically have an interface or a series of interfaces that are hanging off a network tap or a span port so that we can see a copy of the traffic. Now this is not in band, right? We are not like an IPS, we're in band. We just need to see a copy of the traffic going by our interface. So typically span port or off a tap. The flow sensor sees those Ethernet frames go by and generate net flow as a result of what it's passively inspecting. So again, we can actually generate net flow with this appliance. So where does this want to live? We see this in a number of places. So the Internet Edge is very common, and I'm going to talk about this in the next slide as well, but the Internet Edge, because our appliance is seeing actual live Ethernet frames, we can look into those packets with the flow sensor, because the flow sensor is not responsible for forwarding this packet, right? The flow sensor has a copy of the packet. The original packet is already past the interface and onto its destination. So we have a little bit more time than a typical router, switch, or firewall would have. We have time to inspect this traffic. So one of the things we can do is some application inspection to determine what application is actually riding on that port number, as well as if it's HTTP or HTTPS, can we go in and grab some information such as the URL. Because of that, this can be extremely helpful on the Internet Edge. Even in cases where the Internet Edge devices do support NetFlow, we can get additional visibility that'll help us from both a networking and security standpoint. We also like to place this at the data center edge in many cases, because having certain types of information like performance statistics, round trip time, and server response time statistics for TCP sessions in and out of the data center can provide very valuable insight into connectivity going from the user base into those specific applications. And then again, any blind spot in the network where we just need to generate flow. So we already talked about network, newly acquired network or site. Certainly the network team, maybe the security team purchased Stealthwatch, but the network team owns the network and does not want to turn on NetFlow. Well, how do we get visibility? We could potentially deploy flow sensors to provide the flow visibility we need for the tool. Also, maybe you have a third-party managed partner in there. Maybe your wide area network is managed by a third party, and the existing contract for management does not involve the fact that you can get NetFlow. So you're going to have to wait for a new contract cycle before that can occur, or an update to the contract. Or again, any case where a device cannot generate flow. This could be consumer grade gear that is not flow capable. This could be hardware that's just taxed. Maybe it's an old router that is already running at 80% CPU and we don't want to turn an additional feature on. There's a lot of times and places we can choose to deploy a flow sensor, but again, it's optional. It's not required for the solution, but it can help you gain additional visibility into what's happening on the network and into portions of the network where we don't currently have visibility today. A little bit more information about the flow sensor since it is so unique. I mentioned the fact that we can dive in with the flow sensor because we have the packet a little bit longer. We don't necessarily have to forward the packet. We're not going to introduce any latency because of how we're inspecting a secondary copy of the packet. We can look at that data and perform deep packet inspection and determine what it is. So as an example, even though it's running on a high numbered port, we can tell you that it's FTP or HTTP or HTTPS or some other protocol. We can tell you that that conversation on port 80, which we'd expect to be web conversation, is actually a Facebook conversation, or is some other conversation like it's FTP or Telnet that's running on a non-standard port. If it happens to be HTTP or HTTPS, we can extract additional data. With HTTP, because it's non-encrypted, we can pull the get or post strings that are part of that conversation. So we can go in and tell you the URL, which again can be very interesting for a couple reasons. For networking, you can then choose to filter on this field and say, I only care about flows where the user was in this particular web path. For security reasons, there are a number of botnets that are out there that even though the footprint may look different on a Mac or a PC because the virus itself changes when it gets to disk, the language they speak back to command and control is standard. So if we can look at those URLs and we can see the conversations that are occurring, we have the capability to look at that information and be able to potentially passively identify just by looking at the HTTP strings what botnets are on the network and what hosts are infected. Now with SSL on the right-hand side of the screen, it's a little bit different. Certainly with SSL, the URL portion is encrypted, but we can gather some information off the certificate, such as common name in the organization. Now, one other thing I want to mention here related to the flow sensor, but actually all of the appliances, is they all have the ability to perform packet captures. Now, the flow sensor is a unique place to mention this because the flow sensor has access to live customer traffic. It actually can see the live Ethernet packets on the wire. I mention this here because this can be a very, very interesting way for the security team or network team to perform different types of investigations on the network. By deploying a flow sensor, they now have a capture node that they can leverage to perform a live packet capture of real traffic and then pull that PCAP back for further analysis. So it's sort of an added benefit, if you will, of deploying a flow sensor. Now, all of the other Stealthwatch appliances do have packet capture capabilities. However, most of those cannot see live customer traffic. They're processing flow data or specifically just communicating with other appliances in the solution. But we could use those for troubleshooting the packet captures there, for troubleshooting the conversations to the network, the email, a whole bunch of other scenarios. Final portion here as it comes to system components with Stealthwatch is there are a lot of other licenses that can be integrated, whether it's the ICE integration, the threat feed, the cloud license. We'll talk a little bit about some of this as we move forward, but again, the heavy lifting is what we saw in the middle of the page, the management console, the flow collector, and getting flow into the solution. If we choose to add in flow sensors to augment the flow data we have or add additional flow data, we can do that. We can certainly use the UDP director to simplify some of the flow collection and syslog and SNMP collection architecture. And then again, to add additional context to the data that we've obtained from the network, choose to add in additional licenses. Now, at this point of the deployment, these are things that show up on the bill of material, and you'll certainly just have to integrate what's been provided. But it's always good to know what other capabilities are out there so you can discuss that with